The desert airstrip was quiet at first light, the kind of quiet where every sound feels amplified. The metal of grounded fighters ticked as they heated under the rising sun, and dust drifted across the runway like smoke from a dying fire. Most of the base was still waking up. Mechanics stretched. Pilots sipped burnt coffee. No one expected anything unusual. They thought today would be routine. They were wrong. At the far end of the runway sat a battered P-51 that shouldn't even have been flying. Its paint was scraped, its fuselage patched. One panel still wore the chalk marks stripped for parts. But something was different about it today. Something subtle, yet unsettling. The engine cowling looked fuller. A new intake shape protruded slightly, as if the aircraft had grown an extra muscle overnight. Only one man knew why. Clay Dawson stood beside the plane, hands blackened with grease, eyes burning with a quiet confidence. While others slept, he had transformed the fighter into something no regulation manual had ever imagined. A handmade hybrid engine, an intake spiral hammered from scrap metal, components stolen from junk piles and remachined by hand. A backyard engine, as the other mechanics joked, until they saw it turn over. The test pilot, Lieutenant Mark Riley, walked toward the plane with a grin that didn't hide the nerves behind it. He wasn't reckless, but he loved being the first to try something dangerous. "You sure this is going to hold together?" he asked without slowing his stride. Clay didn't answer right away. He wiped his hands, stepped closer, and spoke in a low voice meant for only two people on Earth. "It won't hold together," he said. "It'll climb." Riley stared at him for a long moment, then, without another word, he climbed into the cockpit. The canopy slid shut. Clay placed a hand on the nose, feeling through aluminum the pulse of a machine he'd built with his own stubborn defiance. Engines were supposed to come from factories. His came from belief. When Riley hit the starter, the air around the aircraft seemed to tense. The engine coughed, shuddered, then roared with a tone no one on the airfield had heard before. It wasn't smooth, it wasn't gentle. It sounded alive. The nearest mechanics froze mid-step, tools still in hand. Two engineers walked out of the hangar, squinting as if their eyes might be deceiving them. The vibrations rippled across the ground and rattled windows. Something was definitely wrong, or very, very right. Riley released the brakes and the P-51 lunged forward. Dust exploded behind it. The plane accelerated faster than any Mustang had business accelerating. Men started running toward the runway, shouting for it to abort. But the fighter was already gone, wheels lifting clean off the earth in half the distance normally required. Within seconds, it climbed steeper than a stock engine could handle. At 500 feet, chase planes scrambled. At 1,500 feet, they were already falling behind. By 3,000 feet, the modified Mustang wasn't just climbing. It was vanishing into a silver streak, slicing through the morning air like it had somewhere urgent to be. One engineer whispered, "What the hell did he build?" Another answered, "Something we didn't approve." And at the end of the runway, the only man not shocked was Clay Dawson, arms crossed, watching his backyard engine break every rule he'd been told to follow. He didn't smile. He didn't cheer. He simply breathed out and said almost too quietly to hear, "I told you it'd climb." For years, the U.S. Army Air Forces held one belief so deeply that no one even questioned it. A fighter engine could only come from Detroit, Wright Field, or the polished floors of an approved contractor's plant. Precision machining, regulation tolerances, standardized metallurgy, these weren't just guidelines. They were doctrine. You didn't improvise a fighter engine. You didn't modify it. And you definitely didn't build one out of scrap with your bare hands. Mechanics were taught a single mantra from day one. Follow the checklist, or you're done. Inspect, replace, report, sign. Anything that didn't exist in the manual might as well have been a crime. The penalty wasn't always jail, but it could be worse. Grounding, reassignment, or being labeled unsafe, a career death sentence in wartime. Innovation was welcome only when it came from the top. From the bottom? Absolutely not. So when Clay Dawson arrived on base, a quiet farm kid from Arkansas who fixed tractors with fence wire and tuned engines by listening to the vibrations in the block, nobody took him seriously. He asked questions mechanics weren't supposed to ask. Why can't the intake angle be sharper? Why does the manifold heat half the air for no reason? Why does the Merlin choke at altitude when a simple bypass valve could ease the pressure? Every question made the senior engineers glare harder. Every suggestion earned the same answer. Because that's not how it's done. Clay saw something different. To him, engines weren't sacred artifacts. They were stubborn animals waiting to be tamed. It didn't matter where the parts came from, Detroit or a junk pile, so long as the machine breathed better, burned cleaner, and pushed harder. He believed fighters weren't limited by what factories built. They were limited by what mechanics were allowed to change. And he wasn't alone. Pilots whispered the same frustrations after every mission. Stall-outs at 25,000 feet, sluggish throttle response under dive recovery, engines that overheated simply because the airflow system was built for mass production, not battlefield reality. The P-51 was brilliant, yes, but it carried flaws everyone accepted because the rule book said to accept them. Clay refused. The misconception wasn't just mechanical. It was cultural. It was the belief that innovation required a degree, a lab, a badge. That genius only came from the approved pipeline. But war has a way of shattering illusions, and the front line doesn't care who invented the idea that saves a pilot's life. Clay understood something the engineers didn't. Perfection didn't come from regulations. It came from results. By the time rumors started spreading about a mechanic messing with things he shouldn't, the officers dismissed it. The chief engineer called him a backyard tinkerer. A captain joked, "The only thing he'll build is a court-martial." They all laughed. They all underestimated him. Because in a single night with nothing more than scrap metal, stolen hours, and a brain wired for impossible problem-solving, Clay Dawson built an engine no factory had imagined. An engine that would tear through the sky like it had been waiting its whole life to run. And after the test flight, no one was laughing anymore. Clay Dawson didn't come from a family of engineers. He didn't grow up around aircraft, blueprints, or manufacturing plants. He grew up in a one-road Arkansas town where engines were tools, not trophies. His father repaired tractors, water pumps, and anything else stubborn enough to break during harvest season. Clay learned early that machines often lied about what they needed. Rattles that sounded like bearing failure turned out to be loose bolts. Smoke that hinted at a cracked block turned out to be nothing more than overfilled oil. His education wasn't formal. It was earned through busted knuckles and the unspoken rule of rural life. Fix it with what you have, not what you wish you had. As a teenager, Clay built engines from junkyard scrap. He combined mismatched pistons, filed down rods by hand, and tuned airflow with cut-up stovepipes. His neighbors joked that he could make a lawnmower outrun a pickup truck if you gave him a weekend. By 18, he could identify compression issues by sound alone. He didn't know calculus, but he understood combustion like it was a second language. When the war began, he enlisted, not because he dreamed of flying, but because he wanted to work on machines that didn't come from a salvage pile. Basic training hated him. He improvised fixes nobody approved. He ignored half the manuals, claiming the people who wrote them had never touched a real engine in their lives. He was written up twice, almost discharged once, and labeled a maintenance risk, more than any mechanic in his unit. But every time something truly broke, really broke, the officers called for him. They didn't trust his rule-breaking, but they trusted his results. A lieutenant once said, "If Dawson can't fix it, bury it." At his assigned airfield, Clay saw the P-51 Mustang for the first time. Sleek, fast, elegant, yet flawed. Not fatally, but noticeably. Its engine ran beautifully below 20,000 feet, but struggled above that, starving for cool air and choking on turbulent pressure. The supercharger worked, but not efficiently. The manifold wasted energy. Clay didn't see a masterpiece. He saw a machine begging to breathe better. He started sketching redesigns during lunch breaks. New intake shapes carved into the margins of ration forms. Better airflow paths doodled onto scraps of sandpaper. a compression ratio change penciled on the back of a fuel report. He wasn't trying to defy the system, he was trying to improve a design that seemed frozen by bureaucracy. But the more he observed the aircraft, the more he realized something factories never accounted for: real combat. Dust clogging filters, altitude swings snapping hoses, vibrations loosening bolts that were torqued exactly to spec. In the field, engines weren't lab specimens. They were survivors. Clay's mind connected problems the way only a self-taught mechanic could, unconstrained by the limits of textbook thinking. Still, he kept his ideas quiet. Officially, he wasn't allowed to modify anything beyond standard repair procedures. Mechanically, he could have rebuilt the entire aircraft from the ground up. Politically, he was supposed to do nothing but follow orders. But war doesn't reward obedience. It rewards solutions. And when a crippled P-51 rolled back to base one afternoon, oil leaking, hoses burst, airflow system warped by a near miss, Clay saw an opening. A pilot begged him to save the aircraft. Command wrote it off. Engineers said the damage was non-serviceable. Clay stood between a rule book and a broken engine and made the only choice he'd ever known. He ignored the book. That decision would change aviation forever. And in less than 48 hours, it would produce a machine no one believed possible, a backyard-born engine that left every fighter of 1944 gasping in its wake. Before Clay Dawson ever touched the crippled Mustang, the data was already screaming for someone to break the rules. Engineers at Wright Field had pages of performance charts, altitude curves, fuel flow diagrams, and maintenance logs. Yet they all missed the same truth. The P-51's brilliance came with hidden weaknesses that battlefield conditions magnified tenfold. At high altitudes where bomber escorts fought for their lives, the Merlin engine lost efficiency far faster than anyone expected. At 25,000 feet, the air thinned, the supercharger strained, and the mixture system fed the engine air that was both too turbulent and too warm. The official solution was to increase throttle with caution, a phrase pilots hated because it meant nothing in real combat. Clay saw it differently. He understood that airflow didn't just cool the engine, it dictated how the engine breathed, how it burned fuel, how it produced power. If the airflow was wrong, everything else was wrong. Maintenance records showed that over 30% of engine failures in high-altitude escort missions were caused by temperature spikes that the standard system couldn't handle. Field units consistently reported power loss that engineers dismissed as pilot variance. But Clay had watched enough returns to know better. He'd seen engines come back coughing like they'd inhaled sand. He'd heard the hollow sputter of a supercharger starved by poor intake geometry. And he'd seen Merlin seize because a textbook-written airflow model couldn't compete with a sky full of gunfire, dust, and violent dives. Fuel consumption was another silent enemy. The P-51's effective range depended on precise burn rates that rarely matched battlefield reality. Pilots pushed power settings to stay alive, not to meet factory efficiency curves. Command expected perfect mixture ratios in imperfect conditions. Clay knew this was fantasy. The engine wasn't running lean because the pilot misjudged. It was running lean because the system wasted half the air it pulled in. The numbers didn't lie. They were simply ignored. Even the aircraft's speed ceiling, officially around 440 to 445 mph, wasn't as firm as everyone assumed. Clay had seen Mustangs hit higher speeds when they were damaged, stripped of panels, or had airflow disrupted in unusual ways. To most mechanics, that was coincidence. To Clay, it was an opportunity. Turbulent airflow wasn't always a flaw. It could be harnessed. But no one else bothered to test it. Then there was the most damning statistic of all. Frontline mechanics spent twice as many hours fixing imperfect systems as pilots spent flying them. Every shortcoming cost time, aircraft, and lives. And yet nobody dared propose radical modification. The manuals said, "Do not alter." The engineers said, "Do not improvise." The officers said, "Do not deviate." Clay saw a battlefield built on denial. He wasn't guessing. He wasn't gambling. He was following the numbers to the conclusion no one wanted to admit. If the Mustang was going to perform at the level the war demanded, someone had to build an engine the factories never approved. Someone had to break the rules that kept pilots safe only on paper. Someone had to rethink the airflow problem from the ground up. Clay Dawson didn't start with theories. He started with the data that everyone else brushed aside. And buried inside that data was a simple, revolutionary truth. The P-51 didn't need a new airframe. It needed to breathe differently, and Clay knew exactly how to make that happen. Clay didn't build his engine in a lab, a factory, or a wind tunnel. He built it behind the maintenance shed, on sun-warped planks, surrounded by crates of scrapped parts the Army considered worthless. To everyone else, that yard behind Hangar 12 was a junk pile. To Clay Dawson, it was a library. Every bent duct, cracked manifold, and discarded supercharger housing told him a story. What the airflow wanted to do, what the engine hated, what the Merlin was really capable of if the bureaucrats stopped strangling it with regulations. The idea started with a single question. What if the intake didn't fight the wind, but worked with it? Pilots always complained about the P-51's temperamental high-altitude breathing, and Clay knew why. The airflow entering the scoop met resistance it shouldn't have. It struck the walls at the wrong angle, swirled in chaotic patterns, wasted energy, and denied the supercharger the one thing it desperately needed: clean, dense, directional air. Clay's backyard hypothesis was simple. Force the wind into a straight, compressed path, and the engine would gain power no blueprint had ever promised. He scavenged a broken P-47 intercooler duct, sawed off the portions that didn't fit, hammered the rest into a crude funnel, and bolted it into a Merlin test frame using fasteners that didn't match and brackets he had to bend by hand. He supplemented the assembly with a curved baffle plate from a wrecked Allison engine. Every official mechanic called the build Frankenstein junk. Clay called it airflow discipline. But the heart of the system, the forbidden nerve in the entire operation, was his experimental fuel-air governor. Regulations demanded factory-set mixture ratios. Clay ignored that. He modified an old carburetor body, inserted a floating ring that responded to pressure changes, and tied it to a custom linkage that the Army quartermaster would have court-martialed him for even looking at. His system adjusted mixture on the fly based on true airflow conditions, not on what a manual believed the conditions should be. It wasn't sleek, it wasn't pretty. It was genius born from stubborn Texas practicality. When he mounted the engine for its first test, even his closest friends shook their heads. The thing rattled, it creaked. Half the bolts were mismatched lengths. The duct looked like it had been chewed by a mule. And the officers watching from the hangar window whispered the same word, ridiculous. But Clay wasn't listening to them. He was listening to the wind. He primed the system, stepped back, gave the propeller a pull, and the engine coughed to life with a growl no one had ever heard from a field-modified Merlin. At first it sounded wrong, too sharp, too aggressive, like the engine was starving. Then Clay adjusted the governor. The airflow stabilized. The tone deepened. The pressure needles climbed past safe limits, then past factory limits, then into a zone the manual said was impossible without tearing the engine apart. The officers outside froze. The junkyard engine wasn't failing. It was making power. Clay didn't cheer. He didn't boast. He simply listened as the pitch climbed higher than any stock Mustang on record. His crude funnel duct was compressing the air exactly the way he'd imagined. His forbidden governor was delivering fuel with perfect timing. And the Merlin wasn't coughing anymore. It was roaring. He shut the test down only when the frame began shaking so hard the bolts threatened to shear. Not because the engine was struggling, but because it wanted even more power than the wooden stand could handle. The brass called it luck. Engineers called it a dangerous stunt. Mechanics called it madness. Clay Dawson called it step one. The day he proved his backyard engine could survive its own birth, the war changed direction, and nobody realized it yet. The next morning, Clay rolled the modified engine back into the testing bay, now mounted on a reinforced steel stand because the wooden frame from yesterday had come apart like matchsticks. The officers expected the second test to expose the flaws they were certain were hiding in Clay's invention. They believed yesterday's success was a fluke, a mechanical hiccup, a quirk of pressure or temperature. Engines didn't magically gain horsepower from scrap parts and improvisation. Not in theory, not in books, not in any engineering course the Army had ever taught. But aviation history has a habit of being rewritten by the men who never went to engineering school. What Clay had accidentally built was a hybrid air ram and pressure-stabilizing intake, a primitive form of variable geometry ducting that wouldn't be officially invented for another decade. His scrap metal funnel, mocked as the garbage chute by the mechanics, reshaped the incoming wind into a compressed stream that fed the supercharger a higher density air mixture than the P-51 had ever been designed to handle. Instead of turbulence robbing power, Clay's strange, hammered-together funnel converted chaos into thrust. The engineers observing the test couldn't believe the readings. The airflow remained stable even as RPM increased. Pressure curves smoothed out. Fuel atomization improved instead of degrading. The entire setup behaved like a system that had been designed through wind tunnel research and precision machining, not one hammered out behind a hangar with tools that barely worked. But the strangest part wasn't the intake. It was the fuel-air governor. Clay's floating ring wasn't a real pressure regulator. It wasn't supposed to be anything more than an experiment. But by pure accident, or divine mechanical providence, it responded to airflow density in a way no manual-governed carburetor ever could. When the compressed stream surged, the modified governor shifted mixture without hesitation. When RPM dropped, it compensated instantly. It behaved like an early form of mechanical feedback control, something engineers would later spend years trying to perfect. The officers in the observation booth saw none of this. To them, Clay was simply pulling levers and turning wrenches at the right time. Only the engineers understood the impossible truth. The engine wasn't obeying Clay. It was collaborating with him. As the second test roared on, the numbers climbed into forbidden territory. 62 inches of manifold pressure, then 67, then 72. The chart said the engine should have detonated. The manual said the connecting rods should have snapped. The temperature curve said the Merlin should have melted a hole straight through its block. But none of that happened. Clay's airflow discipline kept everything stable. The engine ran cleaner, smoother, and stronger than anything remotely legal. The engineers exchanged glances, half fear, half awe. This wasn't a battlefield repair. This was a blueprint for the future. Clay shut the system down only after the generator powering the dynamometer overheated and seized. The engine itself? Still cool enough to touch near the intake. Still smooth enough to restart. Still powerful enough to terrify anyone who understood the implications. A mechanic whispered, "That shouldn't be possible." An engineer muttered, "We've been building engines wrong." And Clay, wiping sweat from his forehead, simply said, "Boys, that was only half throttle." At that moment, everyone in the room understood something world-changing. The backyard engine didn't work despite the rules. It worked because Clay Dawson, with no formal degree, had just stumbled onto a principle no Allied laboratory had fully cracked yet. And the war was about to feel the consequences. 2 days after the engine tests shattered every chart, every limit, and every regulation in the book, the base commander finally approved what everyone else wanted desperately to avoid. A real flight test, not on a stand, not inside a controlled bay. They were going to bolt Clay's backyard engine onto a P-51 airframe and put a pilot inside it. The chosen aircraft was an older Mustang, scarred, patched, tired. The kind commanders were willing to risk. The pilot, however, was not. Captain Reed Mallory was one of the best test pilots in the entire 8th Air Force, a man who had flown Mustangs through storms, dogfights, and nearly every mechanical nightmare an overworked engine could produce. He wasn't afraid of dying, but he was afraid of dying stupidly, and flying an unlicensed experiment from a mechanic with a reputation for blowing up engines was dangerously close to stupid. When Reed walked into the hangar and saw Clay's contraption hanging off the engine mount, half-polished metal, half-hammered scrap, all attitude, his expression said everything. You sure this thing doesn't eat pilots for breakfast? Clay shrugged. Not unless you annoy it. Reed didn't laugh. He just climbed the ladder, settled into the cockpit, and stared at the unfamiliar geometry of the intake. There was something unsettling about it, almost biological. It looked less like a machine and more like a metallic throat waiting to swallow the sky. Ground crews rolled the plane out under the late morning sun. Officers and mechanics gathered around the runway like spectators, unsure whether they were watching a test flight or an execution. Clay stood alone near the nose of the plane, his cap pulled low, hands clasped behind his back like a man praying for mercy from an engine he'd created out of instinct instead of instructions. Reed throttled up. The sound was wrong. Not bad, just wrong. P-51 engines had a recognizable growl, a throaty war drum of power and pressure. This one had a sharper edge, a whistle under the rumble, like compressed air slicing through a duct built for a machine that didn't exist yet. The fuselage vibrated differently, smoother and faster. Reed taxied down the runway. Observers watched the prop blur into a silver halo. Then he punched the throttle. The Mustang didn't accelerate. It leapt. In 3 seconds, it covered as much ground as a normal P-51 did in 8. By the midpoint of the runway, it was already airborne, violently, gracefully, impossibly climbing at an angle that made several officers instinctively duck. Reed himself hadn't expected the lift to come that fast. He yanked the stick back, eyes wide, heart hammering, fighting to keep up with a machine that suddenly had no interest in flying like a Mustang. At 4,000 feet, the engine surged again. Smooth, stable, hungry. Reed pushed forward on the throttle just a hair. The airspeed jumped like the needle had been kicked by a ghost. Combat speed without strain. Climb performance that belonged to an aircraft 2 generations ahead. And most disturbing of all, the engine temperature, instead of rising, dropped. Reed radioed back, voice clipped with adrenaline. "What the hell did you put in this thing?" Clay, standing beside the radio truck, allowed himself one small smile. A little common sense. Reed climbed higher, 10,000 feet, 18,000, then past 25,000, levels where the Mustang usually lost its breath. But not today. Today it climbed like it was chasing the sun. The officers below stared at the altitude readings in disbelief. A P-51 wasn't supposed to do that. Nothing in WWII was supposed to do that. Reed broke formation ceilings, climbed past 30,000 feet, and the compression duct kept feeding the Merlin like they were still at sea level. The plane became a spear of silver carving through blue sky, faster than the manual said possible, smoother than physics allowed, more responsive than any pilot had ever felt in a piston fighter. When Reed finally leveled out, he whispered into the radio, voice nearly trembling, "I'm flying something from the future." Down on the ground, nobody argued, because everyone had just realized something terrifying. If this engine reached the front lines, every pilot who flew it would become a nightmare Germany had no way to prepare for. Reed barely had time to process what Clay's engine could do before reality shoved the experiment into a war it was never meant to join. 3 days after the test flight, a Luftwaffe recon jet, a Messerschmitt Me-262, slipped across the channel at dawn, scouting Allied bomber formations. It flew too high and too fast for any standard American fighter to intercept. Normally, the Mustang patrols simply watched, powerless, as the jet flashed by like a silver ghost. But this time, one P-51 on patrol wasn't standard. Reed Mallory had been given permission, reluctantly, nervously, to take Clay's modified Mustang into the air for a limited performance validation run. Command expected a routine flight. Clay expected Reed to keep the throttle below 70%. Reed expected nothing except trouble. No one expected a German jet to wander directly into his altitude. The encounter happened so fast, the ground controllers didn't even track it at first. At 24,000 feet, Reed spotted a flicker of sunlight. Too sleek. Too sharp to be a piston aircraft. A heartbeat later, the Me-262 roared past, a streak of metal with engines howling like dragons. Every P-51 pilot on Earth knew the rule. You don't chase a 262. Reed broke that rule instantly. He rammed the throttle forward, past the safe detent, past the red line, past everything the engine had been built for. The modified intake screamed, the airflow stabilized, and the Mustang didn't climb. It pounced. G-forces slammed Reed back as the aircraft lunged after the jet like a predator that had just smelled blood. Down below, the radar station scrambled, confused. A P-51 was accelerating at a rate they had never recorded. Officers stared, swore, and recalibrated equipment, convinced their screens were glitching. But it wasn't the radar that was malfunctioning. It was German doctrine. The Me-262 pilot glanced back and saw something impossible. A Mustang closing the distance. He rolled hard left. Reed followed. The jet dove for more speed. Reed matched it. By all laws of physics and common sense, the chase should have ended the moment it began. Yet Reed's airspeed kept climbing. 420 centimeter, 440, 465. The Mustang's wings trembled but held. The duct-fed Merlin roared like a mythical beast unleashed. Inside the German cockpit, panic bloomed. Jets do not get chased. Jets do not get caught. Jets do not get run down by prop planes. But this one was about to. The Me-262 tried to break away in a shallow climb, a maneuver that usually left all piston fighters gasping in thin air. Reed pulled vertical with him. Clay's makeshift airflow geometry gulped the sky, force-feeding the Merlin like a living organism. The Mustang rose, and for one unforgettable moment, Reed's canopy aligned with the jet's tail. He squeezed the trigger. The 50 cal guns erupted. 3 rounds stitched the jet's left engine. Another burst shattered a stabilizer fin. The Me-262 bucked, rolled, and began a spiraling dive, trailing black smoke across the morning sky. Reed didn't chase any further. He had already proven everything. When he returned to base, the runway was lined with men who had heard the impossible over the radio. Some stared in awe, some in disbelief, and a few, including 2 engineers who had tried to shut Clay's work down, couldn't meet his eyes. Reed climbed out of the cockpit, legs shaking from adrenaline. A captain stormed toward him. "Did you actually engage a jet?" Reed pulled off his oxygen mask, wiped sweat from his forehead, and said, "It tried to run. I just didn't let it." Clay didn't speak. He didn't need to, because everyone on that field already knew the truth. A scrap-built engine from a mechanic who ignored every rule had just turned a Mustang into the one thing Germany never planned for: a jet hunter. The celebration on the runway didn't last long. Within an hour, military police escorted Clay and Reed into a canvas command tent. Inside waited a half-circle of furious officers, engineering chiefs, and legal staff. On the table lay a folder stamped "Classified. Technical Violation. Level 4. Clay's modified airflow unit, the scrap-built duct that had changed everything, sat beside it like a piece of forbidden contraband. Clay understood what was coming. Reed did too. The lead officer slammed the folder shut. "You conducted unauthorized modifications to a combat aircraft. You knowingly violated engineering protocols. You endangered government property. And you," he pointed at Reed, "engaged a jet with an untested, unapproved, and illegal configuration." Reed lifted his chin. "Sir, with respect, he saved my life, and he gave us something that works." "Works?" another officer barked. "It could have killed you," Clay finally spoke. "Or it could save a lot more pilots than it risks." Silence followed. The dangerous kind. The officers exchanged sharp looks. To them, Clay was a mechanic who had crossed a line you don't cross. He'd embarrassed the engineering chain of command. But before the tribunal could continue, a colonel from intelligence entered the tent without knocking. He carried a thin strip of paper, a radio intercept. "It's already spreading," he said grimly. "Luftwaffe signals just reported a new American superfighter capable of jet pursuit. and they are demanding immediate analysis. The tent went quiet. No one had expected this. Not the immediate German reaction. Not the panic brewing overseas. Not the confirmation that a single experimental Mustang, built illegally in a muddy American hangar, had rattled German high command. The colonel turned to the tribunal. "Gentlemen, you now understand the situation. We can't court-martial these men." The engineering chief stiffened. "Sir, rules exist for a reason." The colonel raised an eyebrow. "And wars are won by results." He placed the intercept on the table. "We need this. We need him." He nodded toward Clay. "And for God's sake, we need that engine." The officers whispered among themselves. Clay watched their faces shift, from anger to reluctance to something like resignation. Reed stood at attention, jaw set, ready to take the fall if needed. Finally, the lead officer exhaled. "Effective immediately, this project is sealed under wartime secrecy. No disciplinary action, for now." Reed's shoulders loosened. Clay closed his eyes, steadying himself. "But," the officer continued, "this modification is never to appear in official manuals, reports, or procurement channels. It will be classified as non-standard, not repeatable. If anything goes wrong, we deny it ever existed." Clay almost laughed. "So you're going to bury it?" "No," the colonel corrected him. "We're going to use it, quietly." He slid the airflow unit toward Clay. "Build 5 more, then 10, then 50. You'll coordinate with test pilots off the books." "Under whose authority?" Reed asked. The colonel smiled faintly. "Under the only authority that matters right now, survival." And just like that, the tribunal dissolved. The MPs left. The officers exited one by one. Clay and Reed were alone in the tent with a classified blueprint, a pile of scrap, and the knowledge that they had ignited a revolution the Air Force could never publicly acknowledge. Outside, mechanics and pilots worked under floodlights. Engines roared. Bombers took off for midnight missions. War pressed on. Reed looked at Clay. "You realize they're terrified of you, right?" Clay shrugged. "If they're scared, good. Means they won't get in the way." Reed laughed, soft and tired. "You think this'll change the war?" Clay picked up the modified duct, the metal still warm from the flight. He turned it over in his hands. The welds uneven, the geometry improvised. The engineering brilliant by accident and instinct. "It already did," he said. And somewhere across Europe, in a ruined Luftwaffe command bunker, a German officer stared at the report of a P-51 catching a jet and muttered a sentence that would haunt the rest of the war. "What else are the Americans hiding?" Clay didn't sleep for the next 72 hours. Reed didn't either. They worked inside an old maintenance hangar that had been hastily fenced off with tarps and armed guards, a place the squadron started calling the Black Barn. No one was allowed inside except a tiny circle of hand-picked mechanics and 2 pilots willing to risk flying something the Air Force refused to admit existed. The first night, Clay tore apart 3 spare Merlin engines by lantern light, muttering calculations out loud while Reed handed him tools. The other mechanics watched in stunned silence. They all knew how engines worked. None of them had seen anything like the way Clay thought. He rewired pressure ducts by instinct. He reshaped intake geometry with a sledgehammer. He adjusted fuel flow with nothing but calipers and a sketch in the dirt. What Clay built wasn't an upgrade. It was a new species of power plant born from war, desperation, and a mind that never learned to think inside the manual. Reed finally asked, "Where did you learn this?" Clay kept working. "Didn't. Just listen to the engine. She tells you what she wants." By dawn, 3 more P-51s were fitted with Clay's forbidden system. Custom airflow shaping, rerouted coolant lines, a handmade pressure stabilizer that looked more like farm equipment than aviation tech, and a throttle response hack the engineers would have fainted over. The test pilots arrived second morning. One looked at the exposed welds and raised an eyebrow. "This thing safe?" "No," Clay said, tightening a bolt. "But she's fast." Reed climbed into the cockpit of Blackbird 2, the second modified Mustang. Two others followed suit, engines rumbling. The guards cleared the runway. The colonel overseeing the program stood in silence, hands clasped behind him, the weight of a secret that could shift the entire war pressing on his shoulders. Reed throttled up. The plane didn't accelerate. It launched. Like the runway wasn't ground, but a springboard. The Mustang's tail barely kissed the dirt before Reed was climbing at an angle Mustangs weren't built to survive. Another pilot followed, then a third. Within minutes, all three planes vanished into the morning glare. Clay stood with a wrench in his hand, staring into the empty sky, waiting for the sound. The confirmation that everything they built hadn't just worked, but worked beyond reason. Then it came. Not a roar, not a hum. A tearing sound, faint but unmistakable, the echo of a shockwave punched at the edge of possibility. Not supersonic, not yet, but closer than any piston fighter had ever come. The colonel turned slowly. "Dear God, what have we done?" 2 hours later, the test pilots returned. They stepped out of their planes with the same dazed expression Reed had worn after the jet interception. One removed his helmet and said, "Sir, I outclimbed a cloud bank. A cloud bank, sir. Straight up. Jets can't even do that." Another added, "And radar couldn't track us above 25,000. We were moving too fast for their sweep cycle." Clay just grinned. "Told you she was fast." Word spread quietly through Allied command. Whisper networks, off-the-record memos, high-level briefings delivered behind closed doors. The message was always the same. A mechanic just built the fastest fighter on Earth, and he did it with scrap metal. Germany, without knowing it, had a new enemy. Not a plane, not a pilot, but an idea. By the end of the week, a coded order came from Washington. Expand the project. Do not formalize, do not document. Use results only. In other words, keep the miracle, hide the miracle, win with the miracle. Clay was given a tiny team, a locked hangar, and the freedom normally reserved only for generals and madmen. Reed became his dedicated test pilot, risking his life twice a day to refine something no rule book had allowed. And every night, Clay stepped outside the hangar, looked at the sky, and whispered the same thing under his breath. "Faster. We can go faster." He didn't know how right he was, because 1 month later, high above Europe, German radar operators stared at a blank screen, a dead zone at 30,000 feet, moments before an entire Luftwaffe patrol was wiped from the sky by aircraft they never saw coming. America didn't just gain a new weapon, it gained a ghost built by a mechanic who refused to believe the impossible existed.